Programming pays more. Oh, if you're looking for pay, no, this is where you want to go if you're thinking about pay. Go to this site, levels.fyi. Go here, and you can see these companies pay. These are the companies that pay well, and here's data on all of the different companies. If you're curious about pay, like IBM's pay, if you're curious. Software engineering pays very well, though. So IBM's pay is like pretty low comparatively. Like Google's pay is rather high, right? Facebook's pretty high too. Microsoft's pretty good too. But obviously the stock has a lot to do with some of this. But if you go to something like a Bloomberg or a what are some other ones? If you go to like a Netflix or a Bloomberg, or this is all self-reported data. Lyft is pretty high too. Yeah, Lyft is very high. From like, entry level. Or where's this? Some other ones? Ancestries? No. Let me think of one that's like pretty high. Square, I think it's pretty high. Yeah, reasonably high. Squarespace. Stripe should be pretty high too. Yeah, Stripe's very high. PayPal should be kind of high too. Oh no, PayPal's kind of low. Stripe is kind of interesting. I like Stripe. The guys that put it together are like 30 now, I think, and they're both billionaires. Citrix. Oh. Citadel should be pretty high too. That's one of the financial firms. Oh no, really no data. I'm looking for some financial firms. Oh yeah, Bloomberg is okay. Let me see if I can find any other. Robinhood. Interesting. Not much, but kind of high for some of these. Capital One is a financial firm. I'm looking for the financial firms. Wells Fargo's financial. Oh, okay. Morgan Stanley's. Oh, they don't. Interesting. For another financial firm. Palantir's probably. I don't know. Oh. I don't know. Give me one of the financial firms. Riot. Oh, nothing. Nike? Programmer at Nike. Come on, man. Finance. Where are the finance? Oh, Twitch. Wow. No kidding. L4 at Twitch is 180K. Whoa. L5. Wow, wait. Maybe I should try applying to Twitch again. I really like Twitch. Actually, I use Twitch a lot. I'm on Twitch constantly. We're streaming on Twitch. Huh. I could work at Twitch. That'd be interesting. Blizzard? No data. One more financial firm. Come on. Give me one. Oh yeah, Squarespace. This one is pretty high. Oh, they don't have data. Oh, never mind. I guess not that high. Stand corrected. Oh, these guys. How are they doing? I've seen this company. I've seen their ads. I'm trying to find another. They don't have too many of the financial firms here. They pay pretty well. You can find them on Stack Overflow. Anyway, yeah, if you want to see yeah, you can find them. But if you go to like Stack Overflow, then you go to jobs, and you go to like Hudson River Trading. Oh yeah, there we go. Hudson River Trading. These guys. So, oh, they don't post their pay, but they pay very well. And then there's another one that pays pretty well. Jane Street pays pretty well also. Or do they not have? Like a lot of the price ranges that they post on Stack Overflow, it's actually pretty low. The job numbers, like as you can see, like as you can tell, levels you can see the pay is a lot higher. So you gotta be careful. You gotta negotiate, and just be careful with how when you sell yourself, how you do it. But you can do very well for yourself. You can do very well for yourself. Or very poorly, depending on what you do. Let's finish this video and then we'll get back to programming. But looks like a lot of technologies. Not really. I mean, it's not that bad. Like these things, it seems like a lot at first when you're looking at these jobs, but in truth, it's not that. It doesn't take that much time to get familiar, somewhat familiar, just a basic working kind of knowledge. Yeah, it's not too bad. It's not too bad. But programming pays very well. Yeah. Generally speaking.
And unless the Green New Deal, which will basically clusterfuck the entire world, really can't be done. If they could figure out a way where it was sustainable and people could afford it, I'm all for it, but it's not going to happen. You're going to get more people who think they're entitled to free shit, and sooner or later, it's going to have no say in what goes on with their money and what happens to them. And there's going to be a huge reset, and it's going to be bad for everyone. And I made a little poem about it, so let's see if I remember what it is. Oh, here it is. The coffers of this country, they will one day run dry. But don't you fear, they will indeed be fed. But that cost will be high. It'll be paid in blood and lead.
That's not good. Well, that's not good. This is actually pretty cool. This drone videography. It's a beautiful picture. Beautiful scene. All right. Distractions. Who doesn't love a good distraction? Okay, let's get back to programming here. So, oh, okay. So I said I was going to program today. Or just, oh, wait. Okay. I said I was going to program. So let's do that. So 1:30 or 1 o'clock. Oh man, programming for an hour. This feels terrible, man. Oh, nice. Help my friend out tomorrow. Sweet. Yeah, I'll look to do that. What is it doing? Yeah, all right, we got 1 hour of programming in. Oh, it's so bad. This makes me feel gross. Got hours and hours and hours of doing useless things. All right, so I explained this incorrectly the other day. I wanted to revisit this quickly. The explanation was wrong. So the reason why this works with the tortoise and the hare, really it's the idea is you have the math part. You have x is this guy, and then somewhere here is a k. And so you have the tortoise, and this is when they meet, right? So the tortoise and the hare, x plus k is going to meet 2 times x plus k plus, so minus. So what's going to happen is the hare is going to make a certain number of loops inside here while the tortoise is moving through. And each loop, it's going to be some q times n, where n is the number, is the size of this, is the number of nodes in the is the number of nodes in the what's it called? What do you call that? The number of nodes in the number of nodes in the loop, right? So you got this number of nodes in the loop. Now the reason why you subtract q times n is because you're going to have this 2 times x plus k. It's going to loop some arbitrary number of times, and so each time you loop, you subtract from k, or x plus k. Yeah, that's sort of the deal. It's as if you now, is that totally correct? Actually, I gotta think here. Did I get this wrong again? In my mind, it seemed correct, but now I'm thinking maybe not. Yeah, so this is the, if we suppose for a moment, we suppose for a moment that each time you loop, you don't actually reduce the index that you're on. Like there's some value k that just represents, like, I guess, some number that both of these pointers end up colliding at, and we can suppose that it's not necessarily the index when you're thinking about it this way, if that makes sense. How do I express this correctly? How do I even think about this? Yeah. Okay. This makes sense. This is okay. The way to explain this is if you were to kind of make copies of the loop and just keep extending the linked list to the right, there's some on the linked list that sort of has only one loop, which is x plus k, where k is that index. There's got to be a certain number of loop backs that you're going to do, which is going to be your qn, and that'll make these two numbers equal to each other. So it'll look something like this. It would look something like let's say this is X, and then same thing here, and then this is K, right? So this is X plus K. And then what you're going to do is you're going to have oh gosh. And now you've got this another 1, 2, 3 here. Another 1, 2, 3 here. And this is 2x and 2k. And then there's this loop back, right? So if our loop is like 3, right? So this is the beginning of the loop. 1, 2, 3, 4, 5, 6. So let's say this loop goes back here, right? So these 4 nodes at the end of the loop. Pretty much this is going to loop back to 1, 2, 3, 4 to this node a certain number of times. Oops. And then they're going to be pointing to the same node again. Yeah, and that's the relationship between x and k and n. And so now you have this. It's kind of hard to express it exactly, but pretty much you could sort of put these nodes in a line, and then I make another line underneath where you add more nodes for each sort of loop, and then you have x plus k is a certain spot, and then 2 times x plus k is how far the Hare moves in this extended loop at the bottom. And then you subtract a certain number of times loops to bring you back to where these two meet, where this x plus k meets. 1, 2, 3, 4. Yeah, it looks a little funky here, but I kind of did it in a weird way here because actually that point where that you meet, that's how you calculate these two numbers, and so that actually has to be equal, those two things. So that's how you end up with this relationship. And then from here you can say, all right, that gives you 0 equals x plus k minus qn, which then tells you qn minus x equals k, which then means that which then tells you that k plus x equals 0 modulo n, right? Which is to say that k is equal to negative x mod n, which means, right, same thing here, but that means that you can add x to k. Wherever k is, you can add x to it to get to 0, which is index 0, which is the beginning of the loop. Right, so that's how you do this. I did it wrong before. I said I supposed it was just 1n, and I kind of did the math wrong here. I don't know how. Not really sure how I ended up here exactly. It's the same things, the right conclusion, but the reasoning was wrong. This is actually a little more correct, the reasoning. But anyway, I digress. I kind of messed that up the other day with the explanation. Okay, let's reorder this list. Let's take a look at the discussion. See what other people did. See if we learn anything about this. want to see in C++. Find the middle node. Cut from the middle, first, second half. Merge two lists. Okay, that's what I did. Recursive. Whoa. Reorder node 3, then 2 and 4 to have 2, 4, 3. Then 1 and 5 could have 1, 5, 2, 4, 3. Oh, I see. So it goes from the middle. So you take 2, 4, and 3 and move 4 and 3 into these spots. And then you move 5 and 1 to the. This is kind of strange. Interesting. Huh. I have to think about this, how this works, the recursive approach. Yeah, I did the same thing. Okay. It wasn't particularly. I think the way I did it was pretty good comparatively to how the other folks did it. Pre-order, I'd like to see. Wow, so fast. I don't want to see the Java solutions. Let's think about this recursive solution. So how does he explain it? He says 1, 2, 3, 4, 5. You reorder node 3, then reorder 2 and 4 around 3 to get 2 and then 4, 3. Then 1 and 5 to get 1, 5, 2, 4, 3. How the recursive part of this though, like how does that work? What do you mean? So reorder list of, so you have some tail. I guess it starts from the middle. I don't really understand. Until the length is 0. So this tail is null. Then we say temp is tail next. Wait, does this work on even cases? I think you have a null pointer exception if you do. If you have the length is even. If the length is even, let's say it's 4, then you call this on with a length of 2, excuse me, and then you call it again with a length of 0. The last call, when you call this a length of 0, returns null. So this tail is equal to null pointer, and then you have temp equals tail next, but it's a null pointer exception. Am I crazy? Excuse me. Ah, no. Length is 2. Okay, got it. No. The length is 2, you don't, oh, I see. You never reach that case. Okay, got it, never mind. Take it back. I take it back. You don't hit the null pointer exception. So when length is 2, if head next, return the head next. Space cases. Reordering of this list, and then after you reorder your list, so set some tail to be the reordered list at the next node of the head with length -2. Okay, I think I understand. So if you reorder the list between 2, 3, and 4, right, recursively, so you reordered this appropriately, and you get the tail node, right, head next, and then the whole length -2, right? So 3 nodes. You set temporary value to be the tail next, which I don't actually know what this returns as far as the tail. Well, let's suppose let's suppose it's this one, or rather, yeah, it's whatever node at the end, so it gets rearranged. So you have 2, 4, 3 here, and then tail next would be 5. So I guess the tail would be 3. Why do you want? Why? Excuse me. I don't think you need to do this then, but it gives you the tail. Okay. So you rearrange, and you get the tail, right? Which is 2, 4, 3, the 3. And tail next is then the end, right? 5. Node 5. Set tail next equal to, so temp to be tail next to be tail next. So this 3 goes to null, right? It goes to 5, then goes to null. And then temp next, which is the 5, then goes to the head next, which is the head of right, which is 2. So now 5 goes to 2. And then head next goes to temp. And 5 goes to temp is actually 5. Excuse me. Tail next is 5. Temp is 5. Tail next then points to the null pointer. So this 3 points to a null pointer. Then this head next is going to point to 5. And this temp next, what 5 points to is what head was pointing to. So So 5 points to 2, and then 1 points to 5. Okay, that's interesting. So you take, if you reorder, then you have the last value gets pushed between the front of this reordered list and the head of the list that you reordered, and then that actually works recursively. Oh, that's a very interesting solution. So you reorder the middle and then move the last in front of the first, and the last is then going to point. It's going to point to this sort of new head, and which is just head. So this temp next points to the head next, and then the head points to this temp. Yeah, and then you also take this tail and point it to whatever is past this because you're gonna move this node now. Oh, that is a very interesting solution, and you just need to temporarily grab this value. Wow, very neat. Very neat. And you return tail is whatever when you tail from this list. You return that'll be that, yeah, because you just move this value out. So it's going to be whatever the tail was from this rearranged list. Interesting. And then base cases, you just need to return the tail. So forget if length is 0. If it's length of 1, then you just return the head, right? The tail is the same. If it's length of 2, you want to return head next is the tail. Yeah, you don't touch anything if there's only 2. If there's L0 and L1, it actually it's that base case, you don't move anything around. L0, L1, L2 though, you're going to move L2 between L0 and L1. L0, L2, L1. I just want to go to bed, man. I don't want to keep looking at this stuff. But this is a really interesting solution. Very interesting solution. So right, the tail is just the head of its one node, and you reorder, and then you don't reorder the list, and the tail is just the head next. And then what you do is, right, you reorder what's in between. You decrement your length, right, by 2, these 2 nodes, right, because the length is now just operating on that. Link that list, and once you've reordered, then you want to say whatever the tail is, the tail next. It's got to be, there's some node that comes after the tail. Set that temporarily, and you're going to move that node in front of your rearranged list, between the head and the rearranged list. So you set temp to be that tail next. You set the tail next to point to whatever comes after that node. You set the temp next to point to the head, or head next rather, and then the head next is going to point to temp. And you return the tail. The tail is still the same tail that you had before. And that's it. Really interesting solution. I like this a lot. Very interesting. I probably wouldn't put that in production code, by the way, but it is very interesting. You know what? I'm actually just really tired. I think we didn't get very much programming done today, but I really want to sleep. I really just want to go to bed. We're going to do some more Leetcode problems, possibly. I don't know how much we're going to do tomorrow. Some, maybe. I don't know. I want to lift. I want to play some League. I also want to do some programming, and I also want to help my friend move some stuff. He's moving one house into another, from one house into another. Create an empty stack. Push root node to the stack. Do following while stack is not empty. Create an empty stack. Push the root node to the stack. Following while stack is not empty. Pop an item. Push right child. This is the iterative approach. Using a stack. Yeah. Preorder. That's what I did. Cursive, but it's trivial. Iterate, stack to imitate recursive, right? That's the iterative approach. And then there's a Morse traversal, which is interesting. Okay, yeah, I think I went over all this. Iterative recursive Morse. Yeah. This is the only one that doesn't use the extra space. Or does use constant extra space, yeah. Doesn't use extra space actually at all. It's all already allocated. Okay, we already looked at those things. Pretty neat. Pretty neat. Let's. Yeah, I just want to go to bed. Actually, I feel like guilty. Yeah, we'll look at this tomorrow. I don't want to look at the problem if I'm not going to do it. So let me just go to bed. Let me just go. All right. Thank you all for watching, hanging out, saying hello. I do appreciate it. Talk to you soon. Anyone who likes the stream is lurking. Don't forget to follow. At some point I'll have like socials, like a Twitter and a YouTube and a BitChute and all these things all in one spot. And I'll probably get a bot set up and I'll probably, I don't know, do things to up the ante with the stream a little bit.